I've got another one. In my last couple of videos, I was repairing this DC shuttle circuit for Mark at Donegal Dad Rail, and I don't know if you recall, I replaced the bridge rectifier and stood it off to help it keep cool. Just as I'd repaired this one, Mark found another one that had also stopped working, and asked me to have a look at it as well. Okay, so we have the same board, the same circuit, the same heavily anonymized devices. A quick visual inspection shows nothing terribly wrong with it, nothing burnt or deformed. Focus. What I like about the capacitors is they have a nice flat surface on top. What often happens with these electrolytic capacitors, as they age, they sometimes bow the tops out and then they pop and stop working. But these are okay. There's a slight problem this end where the that conductor seems to have been pulled out of the connector. That's okay. That's an easy fix. That's not the problem. This side, I had a look at that connector and thought, oh, it's burnt. I found the problem. But actually, no, it's not burnt. It looks to be, well, rusty more than anything else. Okay, so the other side of the board, on the previous board I looked at, this device, the PCB around the printed circuit around the device was slightly discolored. It was turning slightly brown. That's not the case here. So, sorry, it was turning slightly brown because the device had overheated. That's not the case here. So everything looks okay. However, let's have a look at the bridge rectifier, because that's, first of all, it's where the current from the controller comes onto the board, and secondly, it's the device that failed on the previous board. So we'll have a closer look at it. I'll pop it out. Well, no, I'll test it first of all. Let's have a look. Okay, so let's have a look at the bridge rectifier. Now, I'm sure you'll find better explanations of how bridge rectifiers work elsewhere on the web, but suffice to say, each one has 4 diodes, and they run from here to here, here to here, here to here, and here to here. And diodes on a DVM diode tester should show about 2 volts or thereabouts in one direction and 0.5, well, 0.6-ish volts in the opposite direction. So let's have a look at this end diode, and that is showing about 2 volts. That's okay. And the other one is about 0.6 volts. So if I swap the leads over in the opposite direction, this one is showing, if I can get it connected, about 0.6 volts, and this one about 2 volts. So those 2 diodes look okay. So let's have a look at the other two. That one there, again, if I can get the lead on. .3. That's a bit high. Okay, and the one down here, 1.3. That's either low in one direction or too high in the other. So let's swap over, swap the leads around and repeat the test here. That looks good. That's 0.6, although it's still a bit higher than I expect. And this one is 0.2. So, sorry, it's 2 volts. So, although that direction looks alright, it's far too high in this direction. And this diode looks okay in that direction, but it's far too high in that direction. Okay, so I think that device hasn't popped, but it's not healthy. So I'll take it out and replace it and see if that helps. A few moments later, I have removed the bridge rectifier, and look, underneath where it was, there's that black skid mark. Now, I remember seeing that on the other device that I fixed. Okay, so thinking about it, it was the same pair of diodes in the bridge rectifier on the other board that had actually failed. Interesting. Okay, let me fit a new bridge rectifier and see what that does. I've also bent that metal conductor back into place. Right, we'll give that a go in a minute. A quick test just before I fit the new bridge rectifier. I've wired up a bench power supply to provide 12 volts to the board where the bridge rectifier would supply it. And if I switch on the power supply, the board seems to be working. Runs in one direction, stops and reverses, and then it should stop and run forwards again. So that's working, and the voltmeter shows the voltage that would normally be applied to the track. So I think I can go ahead now and safely replace the bridge rectifier, knowing that the rest of the circuitry is working as expected. Okay, and finally here we are. I've replaced the bridge rectifier, left it off the PCB a bit just to let air flow underneath it. I've also replaced this connector with a new cleaner one, and there she goes. Runs forward for a bit, stops, runs back, stops, runs forward. I've adjusted the timing just so that we can see what's going on. Right, that'll do for that. So there we have it. two shuttle modules, both failed with the same in the same way. The bridge rectifiers have failed on both of them. I suspect it's something to do with the way these modules are being driven. The bridge rectifiers are intended to convert from a sine wave AC signal to a DC signal, and they do that by having pairs of diodes inside them. On the positive half of the sine wave, the current will flow through one pair of diodes, and on the negative half of the cycle, the current flows through the other pair of diodes. Now this will share any heating effect between the pairs of diodes. When you use a standard DC speed controller to control the voltage to the module, the current that you're supplying only goes through one pair of the diodes. Now, unfortunately, the bridge rectifiers here have been anonymized, so I don't know what their current rating was. The ones I've replaced them with have a current rating of 2 amps, and in fact that's the highest current rating that I could find for a bridge rectifier in that package. So for prolonged use, I'd be inclined to limit the current this module supplies to less than an amp. Okay, if you got this far, thank you very much for watching. And if you're wondering just how many videos can this guy get out of one circuit repair, yeah, this is it, I'm afraid. Unless, of course, you'd like me to talk to you about this one. See you later. Bye.